Aloha, Richard Halverson here. This is ICS321, and this is June 7th, and we are going to finish up chapter 2 today. So let me share my screen. And we are finishing up because today is the 7th. And so I'm going to cover the last two sections of chapter 2. All right, so chapter 2, they took away my table of contents thing on the side here. I noticed that they're messing, this is all one great big piece of software. And so, sometimes they make these updates and, things break as usual. Oh, look, only 17 people have signed up for the course. There's 20 people on the course. Guess I got to figure out who they are. All right, so we finished. We finished a section on view tables, and oh, by the way, I was answering a question by Alvin here, who pointed out that his thing didn't work. Well, I went in and I looked at his tables, and the view original is there. So there's something funny going on with the grader. So I said the problem is with the auto grader. So it's probably that the view question is such an easy question that let's see how many points. Let's see, Alvin got right, yeah, it's 15 more. It's 15. It's 6 more points or so. Yeah, no. So I got to get it fixed. But see, what happens is every now and then I transfer all my stuff to a new server, and a lot of these things that I'm doing depend on certain settings to be exactly right. To grade this, I actually go over and I export your database over to a different server, and then I recreate it. I export it over, and then I run the tests on that exported database, and it looks like there's something wrong with exporting views. And views are tied to an account. To an actual account, because it's like a program, whereas the rest of them are just raw tables. So anyway, that's probably where the bug is. So let's go on, and now we're going to cover normal forms and then the relational algebra, and then we should be done with this chapter. All right, normal forms. Normal forms is all about reducing redundancy in the database. So and mistakes occur because data is oftentimes defined redundantly. Like let's say you have your address, your name and your address, and let's say you have your address in more than one place in the database, and something happens, and you move. It's possible that in one place your address gets updated, and in another place it doesn't. So we can eliminate that possibility by structuring the database properly, and that is by implementing it in as high a normal form as we can, and then we use these joins to combine them back up to get the table with the particular columns that we want. And so you remember earlier in this chapter we talked about joins, and joins become especially important when we after we finish fully normalizing our database, because then after that, to get practically anything, you have to do a join, and you're joining tables in such a way where data is only in one table and they're joined up by foreign keys and so on to create the actual table that you might want for a report. All right, so in normal forms, there's also this concept of dependency, dependence, functional dependency, and column A depends on column B, which means each B value is related to at most one value in A. Now, what does that mean? Here are some examples of redundancy and dependency. Let's see what they're trying to show us here. So here we have a passenger number and a passenger name. So the passenger number determines what the passenger name is. You can think of it that way. And in this particular booking table, passenger number 222, who happens to be Elvira Yin, we see it appears 3 times. And then also the fact that the first class fares board first, that's also repeated a couple times in this table, 3 times. And also each number always has the same, each number, yeah, right, that's what I just, and so passenger number depends on, each number always has the same name. So passenger name depends on passenger number. So passenger number determines passenger name depends on passenger number. And well, what are they going to, oh, and here, same here. The fare is what determines the boarding zone number. So fare determines boarding zone number, boarding zone number depends on fare class. So redundancy is repetition of a value, I guess. It's repetition of related values. Redundancy is repetition of related values. Okay, they have to be related, of course. Tables that allow redundancy might contain inconsistent data. Yes, that's true. Because these have to be the same. If they're not, there's something wrong. If passenger 222 and this is a different name, there's something wrong. Passenger name depends on passenger number means each name is related to at most one number. I don't know, is that true? No. Huh?
Oh no, I just clicked on it and I saw that it was false.
Yeah, these are some mind-bending exercises which you could go through and focus on and kind of get the idea. But this fare class fare class depends on boarding zone number. No, I think it's the other way around. Yes, it's the other way around. All right. Anyway, so we have these things called normal forms, and there's 1, 2, 3, 4. There's 4 important ones. And then there's a couple other ones here which are kind of academically interesting, but they can be important in certain cases. And we are going to look at all of them. We're going to look at examples of all of them. In this textbook, this book, it really kind of only goes up to Boyce Codd, because these are all functional dependencies, and those are the important ones. But there's also a couple of other kinds of dependencies. There's what are called multi-value dependencies, and there's join dependencies. And we actually have a couple of examples of those in our assignments. In our assignments, we have, in fact, in assignment 2, it turns out that this little table where this assignment is more a the mechanics of normalizing. You basically just learn that normalizing is really just doing a projection and then making sure that you get rid of all of the redundant rows that result. Okay, that's all. That's really what normalization is all about. And it turns out that this is actually this table here. You have to reduce this to fourth normal form tables because it's a multi-value dependency. We noticed that salmon steak determines the side dish. And there's two possible side dishes with salmon steak. There's mashed potato and there's white rice. And there's two possible side dishes with beef steak, and that's baked potato and mashed potato. So anyway, and then this also is a fourth normal form example, I think, and it's similar to an example in the book. And then fifth normal form is, I think our last assignment 6 and assignment 7 is actually like a fifth normal form assignment, but you know, it's the idea is we are eliminating redundancy, and each one of the problems that we do, we are eliminating redundancy. And it turns out the way a couple of these problems are posed, the redundancy is right there, and the way to reduce it is just to normalize it more, normalize it farther down, and you'll eventually end up normalized enough so there won't be any more redundancy, which means there won't be the chance of your putting in some data that's wrong and there's some inconsistency. So here's a little dragging exercise for to talk about fifth and fourth. That's interesting. Multi-valued is fourth, and join dependencies are fifth. Just eliminating the first normal form can have all. All first normal form is that there's no redundant rows. The columns are named differently, and each cell has only one value. That's first normal form. So it doesn't say anything about redundancy. It can be as redundant as can be. And then Boyce-Codd is really the one where you want to try to get everything to. And if you find that you have to think about fourth normal form or fifth normal form, you probably won't be thinking about it in those terms. You'll be thinking about, oh, there's redundancy here. I have to eliminate the redundancy, and it's usually pretty obvious when the time comes. All right, so first normal form. The tables in first normal form when all non-key columns depend on the primary key. Okay, so this is an example. This is the key. This will be the key column. This is the primary key, and this would be a non-key column. It's possible that there's two passengers with exactly the same name, and if there's two passengers with the same name, they would have different passenger numbers. So passenger number is the primary key. Table with no duplicate rows, non-key columns always depend on the primary key. I guess that's true. So anyway, go through that. Okay, so second normal form, the only time you ever have to worry about if something is in second normal form or not is if the primary key is a composite key. So in this case, in the booking table, the primary key is actually the passenger number plus the flight code. If you have the passenger number plus the flight code, you are able to uniquely identify which row, which particular booking that we're talking about. Okay. Now, so the passenger number and okay, so but the problem we have here is, okay, so this is going to depend on both of these. This is going to depend on both of these, but passenger name has nothing to do with flight code. Passenger name only depends on passenger number. So we have a case here where we have a non-key attribute or a non-key column that depends on only part of the primary key. The primary key is this plus this. And so what we have to do is we have to separate it out. And the way we separate it out is in our booking table, we have our primary key, which is this plus this. And then we only have the stuff that depends on the whole primary key, and that'd be fare class and boarding zone. And we'll get to the fact that boarding zone number actually depends on fare class. We'll get to that later on. And then, but we separate out the relation of passenger name depending on passenger number, or passenger number determining passenger name. It only takes passenger number to determine passenger name. So that's a second table here. And we can get back the original table by joining this table with this table. And in fact, since the join columns are the same name, then we can use natural join. We don't specify the columns. All right, so that's so this is how you take this thing, which is in first normal form but not second normal form, and you normalize it, so now it's in second normal form. Okay, so that's pretty cool. Here's another example of a table that. So we have student number. Student number determines email address, and we have student number plus course number determines score number. Student number plus course number determines letter grade. So the problem is we have this email address depending just on student number, having nothing to do with course number. So we would separate it out and have one table that just has student number and email address. And then the second table would be this one plus this one plus this one, and not this one, but this one. So you can answer the questions based on that. Okay, so here's the third normal form. Now this booking table that we created up here, that is in second normal form. It's in second normal form because all the non-key attributes depend completely on the full key, but it's not in third normal form because we have a non-key attribute that depends on another non-key attribute. Redundancy can occur in second normal form table when a non-key column depends on another non-key column. And so informally, a table is in third normal form when all non-key columns depend on the key, the whole key, and nothing but the key. So what we need to do is we need to say this depends on this. And of course, this depends on this plus this, because passenger number flight code has purchased a first class ticket, and passenger number and flight code is going to be boarding zone number 1, but it turns out that the dependency, really the direct dependency, is boarding zone number 1 depends on the fare class here. So we separate that out. Since this depends on this, we make a new table, and lo and behold, now fare class is the key to this other table. It was nothing up here, but now down here it's a key, a primary key, and then the boarding zone number depends on that. And then over here we leave booking is just the first 3 columns. We have the passenger number and the flight code, and that determines the fare class. And then over here we see that fare class determines the boarding zone. And to get back this table up here, to get back this table, we just take the natural join of this table and this table. All right, so this sort of defines keys, candidate keys, like for example, up here, you know, we have this, the student number is considered, you know, a key, a part of the key, but like for example at UH, everybody has got a unique student number, which is our 8-digit student number, but everybody also has a unique that part of their email address. And I don't know if every student has, or I don't know if everybody at UH has exactly one. By the way, your student number is also your faculty ID number too. So it's our University of Hawaii number, and then we have our University of Hawaii email address. You know, the first part of our Hawaii.edu. Anyway, so that could be a key. That's a candidate key. So our email address is a candidate key. And then we have this concept of minimal. It can take more than one. Well, okay, so the point is simply that it's like the fewest number of columns necessary to qualify as a key. It's possible to have a collection of columns and maybe one of them isn't really needed, you know, or something. And so if when it's minimal, it means all columns are necessary to determine the uniqueness. All right, but anyway, the database designer usually designates one of the candidate keys as the primary key. So a non-key column is a column that's not contained in a candidate key. So if something is a candidate key, they are not a non-key column. They are a key column, even though they're not. Even though it's not the one chosen by the database designer to be the deemed primary key, the fact that it's a candidate key means it's a key, part of the key, and so that's the definition of that. So a table is in third normal form if whenever a non-key column A depends on column B and B is unique. B is unique. Columns A and B may be simple or is it whenever a non-key column depends on a table is in third normal form if whenever a non-key column depends on another column, that other column is unique. In other words, that other column is a candidate key. That's what determines a candidate key if it's unique. So so that's what that means. In other words, there can't be any non-key columns depending on some other non-key attribute. Okay, so here's an example where if you go through this, you can you sort of go through this and decide whether it's third normal form or not. I did it earlier. What's the fact that's repeated? And the fact that is repeated is not discrete mathematics, because in this example, the math department has a discrete mathematics course and the computer science department has a discrete mathematics course. That could very likely be the case at UH. But what's the duplicate information? Well, the duplicate information is that Azim is the department chair of the math department. We've got Azim. So that's redundant information. Math, Azim. And so what are the candidate keys? Well, in this case, course code. This is a table about courses. So course code could be a candidate key, but also it appears that department code and course name could also be a candidate key. We're assuming that we are assuming that there's only one section. Are we assuming only one section per course? I think maybe we're assuming one section per course. So course code and department code course name. course code and department code, course name, and course name. No, so I think it might be this one. Yeah, okay. It doesn't say about, you know, multiple sections of the same course, which may, because so, you know, in our case, you know, we have CRM, and we can have multiple sections of the same course. So this and this would be the same. This would be repeated, and only this would be different. But anyway, that's not this thing. So anyway, you can go through these and make sure you understand what all of these. What dependency violates the definition of third normal form? The fact that we've got this. Is that? Wait, okay. What are the non-key columns? The non-key columns are department share and course name. No, course name is a key column, because if you take course name plus department code, you have a composite potential. No, you have a it's composite, but you have a candidate key. So so course name is not, so must be this. Yeah. What dependency violates the definition of third normal form? I guess it's we have a non-key column depending on another non-key column. I guess we have this or this. Okay, there. I guess some. Okay, Susan Williams is the head of two departments. What? That's weird. But I guess the department determines the department share and course code. So is it that one? Department share. Department code. Department share depends on department code.
That's the one I selected.
Yeah, I think that's good. Yeah. Course name depends on code. No, that would not be. Okay, yeah, it is. Yeah, that's what I said. Which column should be removed to? Oh, I guess the department code determining department share. So I guess what we get rid of is department share. Yeah. Okay. All right. So anyway, okay. So that's third normal, and the idea here is that you pull out the fact that this determines this, put that in a separate table, and then you have one table that just has these first three columns, and you got another table that's got this column and this column. And the table that has this column and this column would only have 4 entries. Because Z would only be in there once. Susan would still be in there twice, though. I can't be the same Susan. On the mainland, Susan Williams is a really common name. So look, head of the Spanish department and head of the genetics and evolution department. All right. So anyway, okay. So here's Boyce Cod. With Boyce Cod, you it's again. Okay, just like you'll worrying about if it's in second normal form or not, you only have to consider tables that have composite keys. If a table is in first normal form and the table does not have a composite primary key, then the table is also in second normal form. In this, and the same for third normal and Boyce Cod. If the table is in third normal form and it only has a let's see, I better go through this section to make sure that I'm correct before I say something that I have to take back possibly. All right, the definition of third normal applies to non-key columns only, which allows for occasional redundancy. Voice cod form applies to all columns and eliminates this redundancy. Right, so third normal. But we haven't seen the occasional redundancy yet. Okay, so a table is in voice cod if whenever column A depends on column B and column B is unique. Okay, so that means that, yeah, what is it? Anyway, columns A and column B may be simple or composite. This definition is identical to the definition for third normal form with the term non-key removed. Okay, voice cod normal is considered the gold standard. Although fourth and fifth remove additional types of redundancy, these redundancies are uncommon and of little practical concern unless you happen to be faced with the problem that is uncommon, but nonetheless you have to solve it. Okay, so what we have here is so this is in third normal form, but we have this dependency of task name determines project. All right, let's start this and see what it looks like. Okay, employee project task assigns employees to projects and tasks. Each employee is assigned at most one task on each project. Okay. So we have a employee assigns employees to projects and tasks. So this is the project, and this is the task. Okay, so I see. So, oh, I get it. There's a parentheses around here, which means both those two together make up the primary key. So it's these two columns make up the primary key, and the task name is going to. Okay, got it. So on any particular project, or an employee would only be working on one project. No, an employee is only working on one task of a project. The employee is never working on two tasks of the same project. The employee can be working on more than one project, but for any particular project, the employee is only working on one task. All right. So that's third normal form because that determines that. That's for sure. However, we also have the task. The company has a special rule. Tasks names are never repeated on different projects. Task names are never repeated on different projects. In other words, a project name depends on the task name, which is not unique. Task names are never repeated on different projects. So if you know the task name, you know the project name. Is that what they're saying? I guess that's what they're saying. If you know the task name, then you know what project it's on, because you'll never have you'll never have two projects with the same task name. Yes. Okay, great. So that means task name determines project name. Well, okay, so this is not in voice cod because we have a non-key attribute determining a key attribute. A project name is a key. It's a key. Project name is not a non-key attribute. It's a key attribute. It's only part of the primary key, but nonetheless, the fact that it's part of the primary key makes it a key attribute. And we have this non-key attribute determining the project name. If you know the task name, then you know what the project name is. All right, so I guess you got to pull that out. You got to pull out task name, which determines project name. And then you got the employee and the task name over here. So, oh, employee ID and task name is over here. And if you want to know what project that employee is working on, you got to go over here and take the task name, and that'll tell you what the project name is for that task. Okay. So so this is an example of a table that is in third normal form, because all non-key attributes are determined by the primary key. And but not all key attributes are determined by just the primary key. In fact, we have a key attribute that's determined by a non-key attribute. So anyway, that's voice caught. And so you can go through here and make sure you understand voice cod. Employee ID is the only candidate key. Okay, so this is employee ID, and we have driver's license number, and we have driver's license state. And this is the name of the employee. And this is where the employee lives. Okay. Area code, and so it's 306. It turns out that driver's license number plus driver's license state is enough to uniquely identify the employee. So that's also the candidate key. This plus this is a candidate key. This is a candidate key. And so we would choose this, but nonetheless, this and this are make up a candidate key. And the thing we see here is that postal code is in here. Postal code determines the state. Okay, so if you know the postal code, you know the state. And so driver's license state depends on postal code. Well, that means it's not in BCNF. In BCNF, we have to pull driver's license state out of there. Okay. And so we have a separate table that's got postal code and driver's license state. And then we have the bigger table that's going to have this and this and this and this. The bigger table is going to have employee ID, driver's license number, the postal code, and the smaller table has got postal code, which is going to be the primary key, and driver's license state is the non-key attribute. All right, so that'll get you through these. Okay, trivial dependencies. Did I do this one? I didn't do this one. What column depends on TLD? Let me just start this. What column depends on TLD? Well, TLD is the primary key, isn't it? So wouldn't all columns depend on TLD? I'm going to say all columns do. What columns depend on independent state?
Like none of them?
Well, if you know independence date, you know the independence year. So have you done this already?
I was going through them. I think it was I think I guessed that it was or I did year, and I think that was wrong. I think it should have been
nothing.
None, yeah, because
Okay.
they were like more than one country can have the same independence date, and
more than one country can. Well, the date though can. Well, okay, let's see. So let's see. So this was my answer.
Oh, never mind. I'm wrong. Okay, sorry. Okay.
When in doubt, just try it. That's what's so great about computer science is you just try it and see. You don't need so many other things. You can't just try and see, well, I'm a seamstress and I'm going to make this dress for a person. Well, how would the flary sleeves look? Well, try and see. Oh yeah.
Yeah.
2 days later, so here, but anyway, all right. So anyway, that's that one. What's this one? Table. The table has columns that. The candidate key is that. The primary key is also that. The dependency B determines D. Oh, the table is only in first normal form because we have D is determined by only part of the primary key, not all of the primary key. So, okay, so we have it's a composite key, and so we assume it's in first normal. So it might not be in second normal. It's not in second normal if we have a non-key attribute that's determined by only part. So I'm gonna see this. Is it in this one? Is this right? Oh, good. All right, what's the next one? It's getting late. All right, you guys can do this. All right, so we need to do this chapter. Now, this is a fun chapter because we've learned a bunch of stuff. We've learned how to do a bunch of things. We've learned about joins and selects and projection. I've used that term a lot, projection, which is simply identifying which columns that you want to see when you're doing a select. And we've joined stuff. I think we've talked a little bit about union and intersection and difference. But you remember that from other things that you've learned, if not this course. We have this renaming function, and that's where we will say something is named, and we call it as. We use the as word, and we can rename a column. So when it comes out, the column title is different. And then we have these aggregate functions, which is the group functions, where we can group group rows to get group results together for summing. We want to sum up the values in a column or take the average or whatever, find the maximum. And so it's kind of easy to remember these things because R and G and gamma and so on. I for project, S for select, sigma. So it's basically writing all the select statements that we've ever done, writing them in this algebraic way, okay? And we just put stuff in different places, and they end up looking like this instead of like this, and look like this instead of like this, and we just figure out what the pattern and the trick is, and go through this whole thing, and we understand all this kind of stuff because we've already written select statements or seen select statements or seen these things already, and we can it's just the notation. And so after we're done with this, then we can feel like we know the underlying mathematics of this, relational databases. So here we go. Match the symbol with the operation name. Select is the sigma, and project is the pi for project. Times is product, that's multiplication. Join is this thing, bow tie thing. Union is union. Intersection is upside down union. Difference is subtraction. And row name is rename. And aggregate. All right. So this is how we write select. The expression is the while. And since we're not specifying any column names, there's no project. Here we're specifying column names. So this is just like this. This is like we're selecting this from a table where there's no expressions. You don't see a where here. You don't see a where here. So there's no where here, but you're identifying a subset of the columns. So here we are selecting all the records where the salary is greater than 50,000 from the table, from the employee table, and we only want to see the name and the salary. See, so salary over 50,000, that would be this, that would be Lisa and Maria. And so Lisa and Maria, and we only want to see the name and the salary, name and salary, and it's the employee table. Refer to the employee table in the above, indicate whether the following expression pairs define the same table. Oh, different ways of saying the same thing. Yeah, that's right, I remember this. So here we're selecting all the employees greater than 50,000. Here we're selecting everything from a table that's, so yeah, these look like they're the same. Are they? Oh yeah, look at that. Reversing the order doesn't alter the expression. Okay, how about this one? First, we're selecting everybody that's made more than 50,000 on a salary, out of employee, and we get selecting all the columns. And then we're selecting out of that, everyone that got a bonus of over $10,000. Is that up here? Oh yeah. So first it's over 50,000. So that's this guy. And then bonus over 3, so it's Maria. How about this one? Bonus over 10,000 and salary over 50. I think those are the same also. Okay. This one is so the top one is we're selecting everybody over 50,000, and then we're looking at the name and the salary of those people. The bottom one, we're selecting, we're just getting the salary, and then we want the salary. This won't work, will it? Because the name is not being carried. Here we're only projecting the salary. So this sigma will work because we have the salary, but then the name doesn't come out. So I'm going to say false. So there. Okay, here's doing products and joins. So this is how you express it. So cross join, that widely used type of join that we use all the time, cross join. I'm kidding. But anyway, that looks like this, and expression. Okay, so that's equivalent to this. Right. Join operation is written like that, and the identical is identical to a product followed by select. Yeah, okay, that makes sense. Okay, so that's how you express it. The join operation is equivalent to that. Inner join, the join expression is denoted by the Greek letter theta. It's called a theta join. So is that what an inner join is? Oh, the bow tie. The bow tie represents inner join. Whereas left, right, and full joins are denoted by those symbols. Well, what do you know? Those are quite the interesting symbol. Okay. All right, so we're supposed to see what this is. Well, you can see what that is. We are doing, oh, this is the join. Okay, so we're joining department and employee with department manager equaling employee ID. And so we get all those people, and then we want to project department name and employee name. Oh yeah, that makes sense. All right. Referring to these, How many rows are in the table defined by the following expression? Department times course. I don't know. There's no any other kind of thing like that there. So it must just be 3 times 4 is 12. But then when we add only the records where the department code is equal to course code, we get something different. See, department, we get department code. I guess we're going to have department code, course code, and we're going to have, they're the same, they're the same. Oh, and it's an inner join. It's an inner join. So I guess it's going to be, I would guess this one here. Is this one? Yes. And this one is, how many course names are selected by the following expression? Well, that's quite an expression there. We're interjoining departments and courses. And then we're selecting from that the Department of Art and Architecture. And from that, we're selecting just the course name. And we're supposed to say how many course names are there? Department code. Okay. So, and it's this one up here. Which one is it? I guess it's this thing up here, huh? Oh, here. So how many courses are in the art and architecture? Oh, art and architecture is art, and there's 2 courses. There's art history and oil painting. I would say 2 because it's art history and tunes. Is that right? Yeah, it is. All right, so there's also union, intersect, and difference. And so this is how you express, and there's a union, you can do that in MySQL. Intersection, I think you can do that in MySQL. Difference, I think you can do that in MySQL. And try it. All right, so union operation, huh? ID name and compensation. I guess it just is going to take the 2 columns. Oh, okay. Yeah, so it just takes the columns because of the position of the columns, apparently. And it's union, and since they're different, since this is different than this, because these values are different, then it's going to appear twice. And of course, union, well, intersection is going to take the ones that are common in both, I guess. I guess the intersection would be, okay, union How many rows are in the table defined by the following expression? Student union student would be 4. Employee intersection student would be none because there's none that are common. Employee minus student, there's employee minus student. Well, you take employee and you take away all of the rows in student that are also in employee, and then you take those out of employee. So if there's any records here that are in here, you take those out, and you're left with a smaller set of employees, but there's no common ones. So I guess how many rows are in the table defined by this expression? It's going to be just whatever employee is, which is 3. And then Maria Rodriguez takes an unpaid leave. She continues as an employee, but her salary is 0. How many rows in the table following this? What? What? Oh, I get it. Maria, this thing turns into 0. When this thing turns into 0, this record is like this record. So that means that if we subtract out the student table from the employee table, Maria is 6381. Maria 0 is common in both, so that one gets removed. So then we're just left with Lisa and Sam. So we're just left with Lisa and Sam. All right. This is how you implement these. Yeah, right. This is how you implement minus in MySQL. Looks more like this. All right. So renaming. These are renaming examples. This will rename manager. Employee as manager. Okay, so we are renaming the table itself as manager. We're taking, see, this is where you have an employee table and you want to join it with another employee table because you want to find out what the name of the manager is. So you want to have Lisa's ID, Lisa's name, and then you want to have Jiho Chen's name, because Jiho Chen is Lisa's manager. Jiho Chen is all 3 of these people's managers. So what we're doing is we're taking the employee table and we're renaming it as manager table, and so now we're calling it that, and we're joining employee table with this newly renamed manager table, where the employee manager field is equal to the manager ID field anyway. So this renames the table, the employee table manager, and then this does the joining of employee with manager. This is the whole thing is the manager table now. On those 2 things being equal, and then this here we are just doing a projection. We just want the employee name and the manager name, and we're renaming those name and supervisor. So we end up with name and supervisor, and this is the names of the managers and so on. Anyway, that's renaming and aggregating. Where are we aggregating? Well, here we're aggregating where we want to select. We're going to select the group column and then this function column. I'm not sure what function column is. Oh, it's the it's whatever it is. So aggregates can be summing, averaging, min, max. It's getting late. So aggregates, renames. We don't really need to talk about that. Oh, okay, I guess we can. Okay, yeah, this is good. Okay, so I think we can finish today. So here, we're okay. So let's do this kind of expression on this. Okay, here's one. We're going to select department code, and we're going to sum up the salaries for each department code. So this is grouped by department code. Okay, what this does is we're selecting records. We're selecting records, and from this table, from the employee table. And it's going to be one record for each different department code. So that's what group by department code does. It's going to be one record. One record will be returned for each department code because we're grouping by department code. So if there's 10 department codes in a table of 100 records, if there's 10 department codes, we're going to get back 10 records. And in those records, in this case, one field is going to be the department code, and then the second field is going to be the summation of all of the salary fields in that department. See, for the employee. So this is the aggregate function that's going on, and this is the actual thing that you're grouping on. It's nice to have that field in there also. And so we have an employee table that looks like this. And we've got two different departments. So the resulting table is going to be two tables, two row records, and we're going to be summing up the salaries. So in the engineering department, we've got, when you add up Lisa's and Jiho's and Pranav's salary, you get 230,000, and so if the marketers, you get 130,000. So that's how that works. And this is a perfectly acceptable, except for it's not the word function. It's going to be one of these things. You can also do things like group concat, and that's where you want to concatenate a bunch of names together, and it comes out in one column, and so you can do a bunch of stuff like that. And I'll show you all these stuff the next time I have my PHP my admin, but it's getting late. All right, so here's a participation activity on renaming these things. So you should get good at this. We're having employee table. We're gonna group up the sums. We're gonna rename it salary, and we're gonna display out everything, the salaries that are greater than 50,000. Okay, so what does this expression do? We don't really need to do query optimization. Okay, you can go through this. I did this. It's pretty easy. But so let me just end this by doing these two things. Okay, this is this does a search. You get ID, name, and compensation from the employee table. Recomputes the total employee count, renames employee table to compensation, renames salary column to compensation. That's what this does. This does 1, 2, 3, 1, 2, 3. Position. Yes, position matters. So I think it's this one. Yes, looks like it is. Okay, what is the result of this expression? All right, I'm going to take employee and I'm going to sum up the salaries. Okay, I'm just going to sum up the salaries, and then I'm going to rename its salary, and then I'm going to display out if the salary is greater than 50,000. So what's the sum of all the salaries? Why, it's 360,000. You add up all these, it's going to be 360,000. I guess it's this one. I bet you this one bet you this number is if you sum up everybody's salary who makes more than 50,000. Bet you that's what that number is. I'm not going to look at it, but anyway, I think the answer is this one. Yes. All right. What is the result of this expression? Okay, so you search and get all the employees with salary more than 50,000. Then you sum up those salaries, and then you rename it. Ah, ha, ha! I bet you it's this one. And let's see. I'm going to add these up. Less than making more than 50,000. So I'm going to say making more than 50,000, right? So that would be 115,000, 115,000. I'm just going to do that. Or 15, 95, and 67. 277. 277. So that's this one. All right. Oh, expressions. The expressions in questions 2 and 3 are the same operations in a different order. Yes, they do. Do these expressions define the same table? Well, no, they don't. What do they mean? Do they define the same table? No, they don't define the same. 50. No, they don't. All right. Anyway, query optimization, regional. Okay, so this is interesting, but it's not that important. But still go through this and look at all the stuff. This is optimization. Yeah, it's like determining the order of things and so on. Because in if this were a procedural language, then you'd have to think about that. But you aren't telling the database management system the order in which to do these kinds of things. Well, in a sense, you are. But anyway, that's query optimization. Then here's a nice relational algebra challenge activity, which you can do. It's pretty straightforward. So anyway, that finishes up chapter 2, it looks like. And so I think that's pretty good. You have any questions?
No, I think that was great. Thank you.
Okay.
Yeah, that helped clear up stuff. Thank you.
Okay. And
Okay.
I will see you next time. Thanks for watching.
Thank you so much. Okay, bye. Take care. Thanks.
Take care.